What exactly is momentum conservation protecting? Is it guarding an abstract, unchanging numerical direction? Let's put it in simpler terms. The universe doesn't allow you to simply change the total direction of motion across the whole system. Instead, the forces at play balance themselves locally, letting different parts of the system borrow momentum from each other, ensuring that the overall motion remains consistent at a larger scale. Let's imagine this. You're standing on a smooth, frictionless ice surface with someone else. When one person pushes, both of you slide in opposite directions. At first glance, it seems like one is exerting force and the other is simply being pushed. But from a higher perspective, it's clear that the entire flow of the system on the ice is reorganized, with one person moving in one direction and the other in the opposite direction. The overall movement sums up to zero, just like the conservation of momentum. You can't have one person flying off in one direction while the other stays perfectly still. The system has to balance. In the energy filament theory, momentum is not just an abstract concept. Instead, it's like the energy sea itself, organizing a complex pattern of directional flows that governs how everything moves. Wherever there is a consistent directional flow, there must also be a corresponding balance maintained somewhere in the system. To illustrate, imagine you're standing on a skateboard and you throw a sandbag behind you. The action of throwing the sandbag doesn't reward you directly. Instead, the entire system, you, the sandbag, and the ground must adjust to ensure that the momentum is preserved. The sandbag takes on some of the backward momentum, and you, in turn, move forward to balance it out. The system is always striving to keep the flow of momentum conserved, even in such seemingly simple actions. Now, think about it in terms of pushing something heavy, like a cart. When you push the cart, it moves easily on a smooth surface. But if you push it onto a rougher surface, suddenly it becomes harder. The friction of the rough surface is creating resistance, which you have to overcome. The harder you push, the more energy you're transferring into the system. You're changing the flow of the system's momentum, and in the process, energy is transferred between the different parts of the system. Similarly, when a car slows down and the brakes are applied, the car's speed decreases. But this isn't just the car stopping. The friction from the brakes and the resistance from the air are absorbing the momentum, and that energy is redistributed. Let's talk about punching. When you're practicing punches with a partner, a missed punch doesn't disrupt much. It's just air being displaced. However, when the punch lands on the target, all of the momentum that you exerted is transferred into your opponent's body and into the ground beneath them. That energy doesn't disappear, it's transferred into other parts of the system, just like the momentum in a car braking or a cart being pushed. At first glance, the momentum seems to vanish, but it's actually being redistributed throughout the system. The punch's energy is split up and spread into smaller flows, maintaining the balance over a larger area. The force of the punch doesn't just disappear. It's transferred to the opponent and then further dissipated. Similarly, consider a rocket taking off. It's not that the rocket just gets to move forward. The rocket pushes gas out at high speed from its engines, which creates a massive flow of energy behind it. In response, the rocket has to accelerate in the opposite direction, counteracting the backward momentum and maintaining the conservation of momentum. It doesn't gain the right to move forward. Rather, it balances the backward energy flow by moving forward, preserving the system's overall momentum. The rocket doesn't get something for nothing. Instead, it's constantly compensating for the energy it expels. Momentum conservation in the universe isn't just about keeping numbers constant. It's about ensuring that the directional balance in the energy sea is preserved. Every action, every push, every motion involves transferring the momentum of the system in ways that maintain this balance. No object or particle can change its direction without affecting other parts of the system. When we apply a force, whether it's in the form of pushing a cart or hitting a target, that force must be accounted for by the system either by pushing something in the opposite direction, or by transferring the momentum to a different part of the system. In essence, Momentum conservation is the universe's way of keeping everything in check and ensuring that no energy is created or destroyed. It simply moves, shifts, and redistributes itself in ways that preserve balance and stability. In the next episode, we'll dive deeper into why certain particles always follow the same path and how the universe seems to force them into these patterns. Tap follow, share it on New Physics, Clear Universe.